Welcome to the new session of the differential equation. In this session, we will discuss about some equations reducible to separable form via reducing to homogeneous equation. See, some differential equation while saying that may not be homogeneous type. We discussed before it is that dy by dx is equal to g of y by x is the differential equation is the differential equation of the form homogeneous. So, maybe while seeing some differential equation may not be homogeneous, but that can be make into homogeneous. So, we can make that is into reducible to separable form via reducing that equation firstly into homogeneous form. See, we can discuss this session with a question. See, I would like to move to first question. Write down the question. Solve dy by dx. Solve dy by dx is equal to x plus 2y minus 3 x plus 2y minus 3 divided by 2x plus y minus 3 2x plus y minus 3. See, I would like to put it as equation number 1. This is a differential equation. This is a first order differential equation, but even though that is not homogeneous and also that is not separable. So, firstly we convert this equation number 1 into a homogeneous type of differential equation, then we will convert that equation into separable equation. See, before making into the this is homogeneous, I would like to put it as this x is equal to capital X plus h and y is equal to capital Y plus k. The capital Y x plus h and capital Y plus k, and where h and k are constants that we will determine. So, we will discuss how we will determine h and k. See, we just replaced small x as capital X plus h and small y as capital Y plus k is there, and we consider this as dy by dx, small dy by dx as capital dy by capital dy by dx. Fine. So, we will check how can we convert the equation number 1, differential equation number 1 into a new type of a differential equation. That new type of a differential equation will be homogeneous. Okay. Converting the equation 1. So, now equation 1 becomes say equation 1 we will convert equation 1 as small dy by dx as a capital dy by dx, capital dy by dx is equal to, so we can write this as small x as capital X plus h. So, capital X plus h and then 2 into small y as capital Y plus k. So, we can write this is equal to 2 into capital Y plus k. See, capital Y plus k is there and 1 minus 3 is there in numerator. See, just we can write this here it is equal to minus 3. So, divided by, in denominator we have 2 into x, instead of x we replace capital X plus h. So, we can write this is equal to 2 into capital X plus h plus, instead of y we have plus y is there, instead of y we replace as y plus k. Okay. So, this is equal to y plus k and we can write this as say y plus k and minus 3 is here, minus 3. Okay, fine. Now, see here we have again I would like to rewrite capital dy by dx as this is equal to capital X plus small h plus 2y plus 2k minus 3 divided by 2 into x plus 2 into h. Therefore, this is equal to 2x plus 2h plus y plus k minus 3. Okay. Therefore, we can rewrite this as dy by dx is equal to, okay, that is equal to x plus 2y plus the remaining part is h plus 2k minus 3 divided by, again we will have, this is here, it is equal to 2 into capital X plus y is there plus y plus 2h plus k minus 3 plus k minus 3. Okay. So, in denominator and numerator and denominator we have x plus 2y, some term in x plus h plus 2k minus 3 and 2x plus y plus 2h plus k minus 3 is there. See, our thought it is that, so we have to, we would think it is that this h plus 2k minus 3 is equal to 0 as well as 2h plus k minus 3 is equal to 0. Okay. So, we just put dy by dx is equal to, we just put, we consider h plus 2k minus 3, h plus 2k minus 3 is equal to 0. This is, I would like to put this as equation number 2, and again I put, I would like to put this as equation number 3, and also I just consider this as 2h plus k minus 3 equal to 0. So, 2h plus k minus 3 equal to 0. This is equation number 4. Okay. 2h plus k minus 3 is equal to 0. Fine. I would like to solve this equation, then I can find the value of h and k. So, just I multiply equation number 3 into 2, this implies that is equal to 2h plus we have 2k instead of 2 into 2k, that is equal to 4k, and 2 into 3 minus 6 is equal to 0. Okay. I would like to put this is equation number 5. So, we have equation number 5 is there, and we have equation number 4 as 2h plus k minus 3 is equal to 0. This is equation number 4. So, I just subtract 4 from 5. So, we will have 2h minus 2h is equal to 0, and 4k minus k, that is equal to 3k, and minus 6 minus minus 3, that is equal to minus 3 is here equal to 0. From here we have 3k is equal to 3. I would like to take this 3 to here. Okay. 3k is equal to 3. This implies from here, sorry, from here we will have k is equal to some 3 by 3 is equal to 1. So, therefore, we found k is equal to 1. Now, we have the value of k, k is equal to 1. Now, we can put the value of k in either in 3, 4 or 5. I just like to put k is equal to 1 in 3. Say put k is equal to 1 in 3. Put k is equal to 1 in 3. So, what will happen? H plus 2 into 1, 2 minus 3. So, h plus 2 minus 3 is equal to 0. Okay, k is equal to 1. So, h plus 2 minus 3 equal to 0. Therefore, we found it is that h plus 2 minus 3, that is equal to h minus 1 equal to 0. Therefore, while taking minus 1 to here, we will have h is equal to 1. So, we found, that is, we can say that k is equal to 1 and h is equal to 1. Sorry, k is equal to 1 and h is equal to 1. So, we found the value of h and k, and k is equal to 1 and h is equal to 1 whenever this value is equal to 0, h plus 2 k minus 3 equal to 0, 2h plus k minus 3 equal to 0. So, we take the value of h and k as 1 and 1, because that will make these two equations are equal to 0. So, we found whenever h is equal to 1, k is equal to 1, this is equal to 0 and this is equal to 0. Okay. These both values are zeros. So, we consider when h is equal to 1, that will be equal to 0. So, that capital dy by dx equal to capital X plus 2y divided by 2x plus y is there. Okay, fine. So, therefore, capital dy by dx is equal to, therefore, capital dy by dx is equal to, capital dy by dx is equal to, sorry, therefore, we write capital dy by dx, okay, therefore, we write capital dy by dx is equal to, capital dy by dx is equal to, capital dy by dx equal to x plus 2y divided by 2x plus y, x plus 2y, x plus 2y, x plus 2y divided by 2x plus y, 2x plus y. Capital dy by dx equal to x plus 2y divided by 2x plus y. See, while considering this equation, we can say that that is homogeneous. See, we can write this as dy by dx is equal to, we can take x 2 out. So, we will have 1 plus 2 into y by, 2 into y by x divided by x into 2 plus y by x, okay, 2 plus y by x. We can cancel x and x. So, we will have while cancelling x and x, we will have this is equal to dy by dx is equal to, dy by dx is equal to 1 plus 2 into y by x divided by 2 plus y by x, 2 plus y by x. So, while seeing this equation, we understood it is that this is homogeneous, because dy by dx equal to some g of y by x is there. So, that is homogeneous. Now, we have to give some substitution. So, we put some capital Y is equal to V x. Say, put capital Y is equal to some V x, put capital Y is equal to some V x, capital Y is equal to some V x. So, capital Y is equal to some V x, this V is equal to first function, x is equal to second function. Okay. See, what will happen, it is that dy by dx, capital dy by dx is equal to some v into derivative of x, that is 1. Therefore, v plus capital X into some dv by dx is there, capital X plus some dv by dx is there. So, we can put these values into here. Therefore, dy by dx instead of dy by dx, I would like to put this is as equation number 6. So, put in 6, put in 6. Therefore, instead of dy by dx, see instead of dy by dx, capital dy by dx, see instead of dy by dx, we just put this as v plus x into dv by dx is equal to v plus x into dv by dx is equal to v plus x into dv by dx. So, 1 plus 2 into y by x, instead of y by x we can replace as v. So, 2 plus y by x instead of y by x we can replace v. Therefore, this is equal to we just write this is equal to 1 plus v divided by 1 plus 2v, 1 plus 2v divided by 1 plus 2v divided by 1 plus 2v divided by 2 plus v. Okay, 1 plus 2v divided by 2 plus v is there. Okay, fine. So, we can take this capital V to here in opposite side. Therefore, we will have x into dv by dx, x into dv by dx is equal to 1 plus 2v divided by 2 plus v minus v. Okay. So, we will have x into dv by dx, x into dv by dx is equal to x into dv by dx is equal to x into dv by dx is equal to, see, x into dv by dx is equal to 1 plus 2v into 2 plus v, while multiplying this is equal to minus 2v minus v square. Okay. So, this is equal to 1 plus 2v 2 into minus v, that is equal to minus 2v, okay, v into minus v square. Therefore, this is equal to minus v square divided by 2 plus v is there. Okay. This is equal to 2 plus v is there. So, we have plus 2v and minus 2v here, we can cancel. Therefore, we will have x into dv divided by dx is equal to this is equal to 1 minus v square divided by 2 plus v is there. 1 minus v square divided by 2 plus v is there. Okay. Therefore, we can rewrite this as, we can take all the terms of x to here, all the terms of v to here. So, we will have in LHS, we will have 2 plus v divided by 1 minus v square dv, 1 minus v square dv, and finally, we will have this is equal to 1 minus v square dv, 1 minus v square dv is equal to dx by x. Okay. 2 plus v divided by 1 minus v square dv divided by dx by x. So, this is the seventh equation. This is the seventh equation. So, from this seventh equation, now we are happy we separated the variables. We found homogeneous equation. From this, we found homogeneous equation. From this after getting the homogeneous equation, we we changed the equation into method of variable separable. We separated the variables. In LHS, we have the terms involving v only. In RHS, we have the term involving x only. See, just write to this one, make this partial fraction. Therefore, 2 plus v divided by 1 minus v square. In partial fraction method, we can write 2 plus v divided by 1 minus v square as this is equal to a divided by 1 minus v plus b divided by 1 plus v. So, I would like to take this is equation number 8. So, just multiply both sides of 8 with 1 minus v square. Therefore, it will becomes as in left hand side 2 plus v only is there. In right hand side, we will have a into 1 plus v plus b into 1 minus v. Okay. Fine. Put v is equal to my plus 1. Put v is equal to plus 1. See what will happen? It is that 2 plus v is equal to 3. So, a into instead of this one, we replace as 1 plus 1 that is equal to 2a. So, while putting v is equal to 1 minus 1 equal to 0. So, remaining part is equal to 0. So, from here we can found a is equal to 3 by 2. A is equal to 3 by 2. Okay. Now, similarly put v is equal to minus 1. Okay. What will happen? Here this is equal to 2 minus 1 that is equal to 1 is equal to, while putting v is equal to minus 1, 1 minus 1 equal to this part will be 0. While putting v is equal to minus 1, what will happen? It is that minus 1 that is equal to 2. Therefore, 2b. Therefore, b is equal to 1 by, therefore, b is equal to 1 by 2. Okay. Now, we have a is equal to 3 by 2 and b is equal to 1 by 2. So, we can write this as equation number 8. Therefore, equation 8 becomes as from 8 we have this is equal to that is equal to 2 plus v divided by 1 minus v square. Instead of 2 plus v divided by 1 minus v square. We just replace this as a divided by 1 minus v. Instead of a, this is equal to 3 by 2. Therefore, this is equal to 3 by 2 divided by 1 minus v plus, so we write this is equal to b divided by 1 plus v. Instead of b, we write 1 by 2. Therefore, plus 1 by 2 divided by 1 plus v. Okay, 1 by 2 divided by 1 plus v. Okay, so that we can rewrite equation number 7 as, now equation number 7 is equal to, now equation number therefore equation 7 becomes as 2 plus v, instead of 2 plus v divided by 1 minus v square, we can write like this. Therefore, 3 by 2 divided by 1 minus v plus 1 by 2 divided by 1 plus v dv is equal to dx by x, is equal to dx by x. Now, we can integrating both sides. So, integrating both sides. Okay, while integrating, we will have this is equal to 3 by 2 into integral of 1 by 1 minus v dv, 1 by 1 minus v dv. Similarly, plus 1 by 2 integral of 1 by 1 plus v dv is equal to integral of dx divided by x, is equal to integral of dx by x. See, we can write this is as 1 by 2, 1 by 1 minus v. 1 by 1 minus v is equal to, 1 by 1 minus v is equal to minus 3 by 2, minus v is here. So, 1 minus v, if we put v u is equal to 1 minus v, du is equal to minus dv is there. Therefore, minus 3 by 2. So, while integrating, this is equal to minus 3 by 2 log mod 1 minus v, minus 3 by 2 log mod 1 minus v plus 1 by 2 log 1 plus v plus 1 by 2 log 1 plus v is equal to log, okay, here we have log x plus the constant of integration is log c is there. Therefore, log x plus log c. Okay, so we can write this as log of 1 minus v and log of 1 plus v is there. Therefore, this is equal to, we can write this as, see, we can write this as, instead of c, we have this is equal to making square. Therefore, this is equal to minus log of 1 minus v whole raised to minus 3 by, whole raised to minus 3 by 2 plus log of 1 plus v, log of 1 plus v 1 plus v whole raised to 1 by 2 is equal to, whole raised to 1 by 2 is equal to log x plus log c is there. Log x plus log c is there. Okay. Therefore, we can write this as this is equal to, we can make this is equal to some log x square making square root. Therefore, this is equal to log of here it is equal to log of 1 minus v square root of 1 minus v whole raised to minus 3, square root of 1 minus v whole raised to minus 3 plus log of square root of 1 plus v, square root of 1 plus v square root of 1 plus v, okay, is equal to log x plus log c. Okay, fine. Therefore, from here we can write this is equal to square root of this is a log of this plus log this. Therefore, this is equal to log of 1 plus root of 1 minus v into root of 1 plus v, that is equal to root of 1 minus v whole raised to minus 3 into root of square root of 1 plus v is equal to, we can write this is equal to log Cx. This is equal to log Cx. Therefore, from here we can write this is equal to root of 1 minus v whole raised to minus 3 into root of 1 plus v is equal to Cx. Okay, is equal to some Cx is there. Cx. Okay, fine. So, we can write this as this is equal to, instead of v, we can write this is equal to root of 1 plus v divided by root of 1 minus v whole cube. Okay, this is equal to Cx, equal to Cx is there. So, we can square on both sides. So, we will have here it is equal to instead of root of 1 plus v is there, instead of root of 1 minus v is there, we will have this is equal to 1 minus v whole cube is equal to c square x square is there. So, we can replace v by y by x. Okay. We just started the problem by giving substitution, by giving substitution y is equal to vx. Therefore, v is equal to y by x is there. Okay, fine. So, we will have v is equal to y by x. So, we replace 1 plus y by x, 1 plus y by x divided by 1 minus y by x whole cube is equal to c square x square is there. Okay. See, 1 plus y by x is there. So, we can write this as 1 plus y by x, we can multiply this is to here. Therefore, x plus y divided by x. So, this is equal to x plus y divided by x whole divided by x minus y divided by x whole cube, x minus y divided by x whole cube is there. Okay. And this is equal to, in opposite side we will have, in right hand side we will have c square x square is there. So, is equal to c square x square is there. So, we will have here we have this is equal to x plus y divided by x into x cube divided by x minus y whole cube is equal to c square x square is there. We can cancel this x and 1 x from here, we will have x square here, we can cancel this x square and this x square is there. Therefore, finally, we will have some x plus y into some x plus y into divided by x minus y whole cube is there. We just took x minus y whole cube to opposite side in right hand side. Therefore, c square into is equal to some c square into x minus y whole cube is there, x minus y whole cube is there. Okay, fine. And now we can replace. We have we substituted this is equal to in first slide. We just put this as c. We have this is equal to small x is equal to capital X plus h. That is, capital X is equal to small x minus h. Capital Y is equal to small y minus k. Therefore, we replace. Finally, we replace small capital X is equal to small x minus h and capital Y is equal to small y minus k. So, finally, we will have this is equal to x plus y, instead of x plus y small x minus h plus capital Y we will replace as capital Y minus k. That is equal to some c square into instead of capital X, we will have small x minus h minus small y minus k. Capital Y is equal to small y minus k whole cube is here. So, we will have this is equal to, we just replace, we have the value of h and k. H is equal to k is equal to 1. In whenever h is equal to k equal to 1, only the equation will works, that we just proved before. Therefore, we will have this is equal to x minus 1 x plus y minus 1, that is equal to minus 2 is there. Some c square into, we will have this is equal to x minus y, and again minus 1 minus 1 is there, that is equal to minus 1 minus 1 plus 1, that will be removed. Therefore, this is whole cube is there. So, finally, we proved it is that this is equal to some c square into x plus y minus 2 is equal to some c square into x minus y whole cube is the general solution of the given differential equation. See, what we done here, it is that we just converted the equation into homogeneous equation. After we reduce it into variable separable form, then we will put we replace the value of b after we replace the value of capital X and capital Y. Okay, I just give you some assignments to do. Therefore, assignment. Question 1, solve x plus 2y minus 3x minus y minus dy by dx is equal to 3x minus 5y minus 9 divided by 2x minus 4y minus 8, 2x minus 4y minus 8. Okay, write down another question. Solve dy by dx is equal to dy by dx is equal to x plus 7y plus 2, x plus 7y plus 2, x plus 7y plus 2 divided by 3x plus 5y plus 6, 3x plus 5y plus 6. Okay. You may try to solve these problems by using this method, and this is a very nice method. Even though it is some lengthy problems, that will be very nice, and it have very good application of the very good applications in basic sciences and engineering mathematics also. Okay, thank you for watching these videos. Continue your watching. Thank you very much.